Hello, this is Keith Graham from Codasip. When you're designing a processor using software, your end goal normally is to design hardware because where you're trying to describe a processor using a processor description language like CODAL. And so when you are writing the software, it's still very important to understand how a software construct relates to a hardware construct because you might be optimizing your design for area, which relates to cost, power, which relates to energy, or time, which relates to performance. Now let's take a look at a very common software construct, the switch. Now the switch is used a lot of, I should say not a lot of times, well you can use other constructs, but I use the switch statement when I have multiple inputs and for based upon some other criteria, the select variable, I want to assign a particular output from one of these different inputs. Now, if you take a look at my switch statement, I have one assigned output, my system out signal, and I have four different options for my assignment based upon my select line. So you can almost imagine I have four inputs with one output. This maps very well into the hardware construct, the multiplexer, or mux. So here is a symbol for a mux. I have four inputs. You can see each input has the same variable that we had in the switch statement, a enable and with a instruction type with a single output and select lines up top. Now let's take a look at actually how that mux would be implemented. Now it's normally would be implemented in two levels of gates. I have a set of AND gates and an OR gate. And my select lines, a lot of designs, you actually have both the positive and the not version available. So I'm going to still imagine that I have two levels of logic. I have a set of AND gates and an OR gate. The select lines will only allow one AND gate to be able to pass its signal through. So let's take a look at that. Now, for the very first AND gate, I have a not of my 0 input. I have a not of my 1 input. Then I have a 1 for my 0 input. Not 1, 1, 1. So you can see that at any one time, based upon the select lines, only one of my inputs have the possibility of making it to the OR gate. Because remember, for an AND gate to be a 1 on the output, all the inputs have to be 1. Now let's take a look at my 0 input. I got both select lines are 0, so not 0 on both those would be actually a 1 to the AND gate. And only if the enable is 1 and it's an R type will this value of the output of the AND become a 1. And then on an OR gate, only one, you only need one input to be a 1 for it to pass a high out or a 1. So you can see how the select lines will only enable one of the AND gates to pass a signal or value through. And in this case, since my inputs were just an AND gate or AND operation, I was able to use a 4-input AND gate for my multiplexer. So this is a way of selecting multiple inputs to one output. Now, how can we use this to improve performance? Now imagine I have a ALU that I might be doing, I could do an add, an OR, and all the different ALU operations. Now, if I have to make a decision before I start performing my add or AND, I'm serializing my operation, which will cost time. On the other hand, I could use a mux where I actually have, I'm using calculating an add all the time. I'm always doing OR and an exclusive OR. I'm always do those in parallel. When the select line comes through, it will only allow the result of the add, OR, and, or exclusive OR, whatever my select lines tell me to go in the output. So the switch can actually enable increased performance by allowing a more complex operation to occur in parallel while I might be doing some circuitry that actually will select which type of operation I want. So the MUX is a very important hardware construct. It's important to understand how your software constructs will actually affect your hardware design. If you like this video, please subscribe to this channel so that you'll be notified when additional videos are published. Have a great day.